Introduction, and equivalent ratios. Comparing quantities. Introduction. We come across many situations in our daily life, where we find a need to compare two quantities. Here, we are comparing the heights of Sargam and a man. We measured Sargam's height as 150 centimeters and a man's height as 75 centimeters. The ratio of their heights can be found as 150 by 75, which is equal to 2 by 1, which is equal to 2:1. It means, Sargam is 2 times taller than a man. The comparison may be done by determining how many times one quantity is of the other. To compare two quantities, the units must be the same. Problem. Find the ratio of the following. A. 30 minutes to 1.5 hours. B. 500 ml to 2 liters. Solution. A. Since the units are different, change 1.5 hours into minutes. 1.5 hours is equal to 1.5 into 60 minutes, which is equal to 90 minutes. Therefore, the ratio of 30 minutes to 1.5 hours is equal to 30 by 90. HCF of 30 and 90 is 30. 30 divided by 30, whole divided by 90, divided by 30, which equals 2, 1 by 3, or 1:3. Therefore, the ratio of 30 minutes to 1.5 hours equals to 1:3. B. 500 ml to 2 liters. 2 liters is equal to 2 into 1000 ml, that is equal to 2000 ml. Therefore, the ratio of 500 ml to 2 liters can be found as 500 by 2000. HCF of 500 and 2000 is equal to 500. 500 divided 500, whole divided by 2000, divided by 500, is equal to 1 by 4, or 1:4. Therefore, the ratio of 500 ml to 2 liters is equal to 1:4. Equivalent ratios. We can compare different ratios to find if they are equivalent. To do so, we first write the ratios into fractions, then convert them into like fractions. If the like fractions are equal, then the ratios are equivalent. Unitary method. In this method, we first find the value of one unit, and then the value of the required number of units. Problem. In a computer lab, there are 3 computers for every 6 students. How many computers will be needed for 24 students? Solution. Given the number of computers for every 6 students is equal to 3 computers. Number of computers for 1 student is 3 by 6 computer. Therefore, the number of computers needed for 24 students is equal to 3 by 6 into 24, that is equal to 12 computers. Hence, 12 computers are needed for 24 students. Percentage Another way of comparing quantities. Part 1. Percentages are numerators of fractions, with denominator 100. They are very useful for comparing quantities. Meaning of percentage. Word percent is derived from the Latin word percentum, that means per hundred. The percentage is represented by the symbol shown. One percent means 1 out of 100, or 1/100ths. 1% is equal to 1 by 100, which is equal to 0.01. Problem. A shop has the following number of shirts, of different sizes. Size 4 is equal to 40. Size 5 is equal to 25. Size 6 is equal to 35. Find the percentage of each shirt size available in the shop. Solution. Given that the number of shirts of size 4 is 40, size 5 is 25, and that of size 6 is 35. So the total number of shirts in the shop is equal to 40 plus 25 plus 35, which is equal to 100. Percentage of shirts of size 4 is equal to 40 by 100, which is equal to 40 into 1 by 100, which is equal to 40%. Percentage of shirts of size 5 is equal to 25 by 100, which is equal to 25 into 1 by 100, which is equal to 25%. Percentage of shirts of size 6 is equal to 35 by 100, which is equal to 35 into 1 by 100, which is equal to 35%. Note that, in this case, the total number of shirts is 100. Percentages, when the total is not 100. Geeta has a necklace made up of 20 beads of 2 colors. It has 12 red color beads and 8 white color beads. In this case, we have a total of 20 beads. How do we calculate percentage of an item if the total number of items do not add up to 100? We need to convert the fraction to an equivalent fraction with denominator 100. In the case of Geeta, the percentage of the number of red beads is equal to 12 by 20. Converting denominator to 100 by multiplying both numerator and denominator with suitable constant. That is, 12 into 5 by 20 into 5, which is equal to 60 by 100, which is equal to 60%. Percentage of the number of white beads is equal to 8 by 20, which is equal to 8 into 5, divided by 20 into 5, which is equal to 40 by 100. That is, 40%. Percentage, another way of comparing quantities. Part 2. Converting fractional numbers to percentage. Fractional numbers can have different denominators. To compare fractional numbers, we need a common denominator. For converting fractions to percentages, it is more convenient to compare if the denominator is 100. Let us learn how to convert fraction to percent. Step 1. Find the number you can multiply the denominator of a fraction to get 100. Step 2. Multiply the numerator and denominator of the fraction, by that number. Step 3. Write down the numerator, with percent. Let us convert fractional numbers to percentages. 3 by 20 is equal to 3 into 5, divided by 20 into 5, which is equal to 15 by 100, that is, 15%. Here, this is a proper fraction. Percentages, related to proper fractions, are less than 100. 5 by 4 is equal to 5 into 25, divided by 4 into 25, which is equal to 125 by 100, that is, 125%. Here, this is an improper fraction. Percentages, related to improper fractions, are more than 100. Converting decimals to percentage. To convert a decimal to a percentage, multiply the decimal by 100%. Or, move the decimal point 2 places to the right, and add percentage. Convert the given decimal to percent, 0.65 and 5.1. Solution: 0.65 is equal to 65 by 100, which is equal to 65 by 100, into 100%, which is equal to 65%. 5.1 is equal to 51 by 10, which is equal to 51 by 10 into 100%, equals to 510%. Converting percentages to fractions, or decimals. Let us look at the table. For 1%, the fraction is 1 by 100, and the decimal is 0.01. For 10%, the fraction is 10 by 100, that is, 1 by 10, and the decimal is 0.10. For 25%, the fraction is 25 by 100, that is 1 by 4, and the decimal is 0.25. For 50%, the fraction is 50 by 100, that is 1 by 2, and the decimal is 0.50. For 125%, the fraction is 125 by 100, that is 5 by 4, and the decimal is 1.25. For 150%, the fraction is 150 by 100, that is 3 by 2, and the decimal is 1.50. Parts always add to give a whole, all the parts that form a whole. When added, together give the whole, or 100%. Hence, if we are given one part, we can always find out the other part. Suppose that the basket is filled with apples, oranges, and mangoes, in which 50% are apples and 30% are oranges. Then what percent are mangoes? Percentage of mangoes is equal to 100% minus 50% plus 30%, which is equal to 100% minus 80%, which is equal to 20%. Therefore, the percentage of mangoes is 20%. Fun with estimation. Percentages help us to estimate the parts of area. Estimate the percent of colors. In the first figure, 1 by 4th is colored. It is equal to 1 by 4 into 100%, that is 25%. Therefore, 25% is colored. In the second figure, 3 by 5 part is colored. 3 by 5 can be written as 3 by 5 into 100%, which is equal to 60%. Therefore, 60% is colored. Concept of simple interest. Charge given on borrowed money, or simple interest. Mohit bought a brand new car by taking a loan amount from a bank. Sonali, on the other hand, deposited money in the bank. This amount is known as the principal. Principal. The money deposited, or borrowed, is called the principal. What is interest? Interest is the extra money paid by institutions, like banks, or post offices, on money, which is deposited with them. Interest is also paid by people, when they borrow money. Interest is generally given in percent, for a period of 1 year. Amount. Amount is the money to be paid at the end of the year, by adding the sum borrowed, and interest. Amount is equal to principal, plus interest. Interest is generally given in percent, for a period of 1 year. If principal is P, and rate of interest is R per annum, then interest I is equal to PR by 100. Problem: if Meena gives an interest of ₹90 for 1 year at 8% rate per annum, what is the sum she has borrowed? Solution: given interest is equal to ₹90. R is equal to 8% per annum. Let the sum be rupees, P, then I is equal to PR by 100. That is, 90 equals to P into 8 by 100. So, P is equal to 90 into 100 by 8, which is equal to rupees 1,125. Therefore, the sum she borrowed is rupees 1,125. Interest for multiple years. If the amount is borrowed for more than 1 year, the interest is calculated for the period the money is kept for. The way of calculating interest, where the principal is not changed, is known as simple interest. Simple interest. Simple interest is defined as the fixed rate of interest charged for a fixed period of time. Or, it is the interest calculated only on the initial amount that is invested. Formula for simple interest. Let principal be P, rate of interest per year be R%, and number of years is equal to T. Then, simple interest is calculated as SI equals to PRT by 100. Amount A is equal to principal P plus interest I. Illustrations on concept of simple interest. Problem: find interest and amount to be paid on rupees 15,000 at 3% per annum after 3 years. Solution: given principal P is equal to rupees 15,000, rate of interest R is equal to 3, and the number of years is equal to 3. Here, interest is nothing but simple interest. Interest is equal to PRT by 100. That is equal to 15,000 into 3 by 100, which is equal to 1,350. Therefore, interest is equal to rupees 1,350. Amount A is equal to principal plus interest. That is, 15,000 plus 1,350, hence, amount is equal to rupees 16,350.